A very good morning to all of you, and here we are going to start the last chapter of this unit, and the name of the unit is that electrostatics, and the name of the chapter is capacitance. Generally, capacitance is related to store the charges. यानी इसका मेन काम क्या है? चार्ज को स्टोर करके रखना, पकड़ के रखना, होल्ड करके रखना. And in our day-to-day life, we are daily using it, isn't it? We are using these capacitance everywhere. When you go to the electrical tubes, when you go to the your television, you go to the your inverter, if you go through the any electrical instrument, you will see that there is a capacitor is there. Earlier it was like a cylinder, now it is made like a chips also, and we will view when we come in the practical classes also, we can see that what is the practically how it is looked. Okay. But before starting the capacitor chapter, we should know what are the conductors and insulators, and how the conductor is behaving in an electrical field. Okay. Now, what are conductors? The materials or the substances, which allow the electric charge to flow through them easily when external electric field is applied, is known as what? Conductor. There are various examples of conductors are, suppose, silver, aluminium, copper, iron, mercury, aqueous solution of salts, bases and acids. And out of this, only silver is the best conductor. Is it clear? Silver is the best conductor. Now, what is insulator? We should know also insulator. The materials or the substances which do not allow electric charge, to flow through them when placed in external electric field is known as what? Are known as insulator. Examples are what? Glass, rubber, wood, then plastics, paraffin wax, nylon. All these things are what? Considered to be what? Considered to be insulator. Now, we know we have some knowledge about that. We know that we come to know that what insulator and conductor. But what is free charge? Suppose an atom is there. In an atom, nucleus is present in the center, and outside it, what will happen? Electrons are revolving around it in a particular orbit. And those who are closer to the nucleus are tightly bounded, and those who are away from the nucleus are loosely bounded. Is it clear? If this electron, the force between that nucleus and the electron also, that they are free to move and give an electric field against the electric field, direction of the electric field, then you can say this charge is what? Free charge. And if they are not able to move when the electric field is given, that means that the force between this nucleus and nucleus and electron is much higher than the force whatever you are giving, so that what? By the electric field, then you can say it is what? Bound charges. That this charge is known as bound charges, and the system is known as insulator. Clear enough? So bound charge means what? Bounded towards the nucleus. And free charge also is what? It is also bounded, but It is what somehow the force between nucleus and this electron is less than the main bound charge. Clear or not? This is about your bound charge and free charge. Okay. Our next topic is that how the conductors behave in electric field. Our topic is what? Behavior of conductors in electric field. And in this, the first point you will see that net electric field inside a conductor is always zero. Why? For that, let's take a conductor, okay, which is uncharged means what? Number of positive and negative charges. We have taken a conductor which is uncharged means what? Here number of negative and positive charges are same, and we place it in an electric field. Okay, so that this side is positive and this side is negative, and the electric field for this, when no conductor is placed here, the electric field from this side to this side is how much? Enough. When you place this conductor inside it, then what will happen? All the negative charges of this conductor will come this side and positive charges will go in that side. That means they will create an electric field among themselves opposite to the direction of this enough. That means the electric field is in this direction. A new electric field will create it in this direction. Is it clear? And the value of this electric field in this direction is EP. And it is found that the magnitude of E naught and EP are same inside it. So the result is how much? EP, E naught minus EP. E naught is what? Electric field given by external electric field, and EP is what? Electric field produced by the conductors. Is it clear? So net electric field is always equal to what? E naught minus EP and is equal to how much? 0. So from there we can say net electric field inside a conductor is 0. Is it clear? Net electric field inside a conductor is 0 because what will happen? When we place a positive plate and negative plate in between the conductor, there is an electric field is created in the conductor, and this, if this side is positive, all the negative of this conductor will come here, all the positive will come here, okay, towards the negative side, and they will what? Create a electric field opposite to the direction of the applied electric field, and they will cancel the effects of applied electric field, and hence net electric field is considered to be 0. This is the second point what I am going to, this is the first point what I am going to discuss about the behavior of conductors in electric field. Is it clear? Our second point is that electric field outside the conductor is perpendicular to the surface. My point is clear. When the conductor is placed in electric field, then the direction of electric field outside the conductor is always perpendicular to the surface. We know when you place a conductor in an electric field, then what will happen? The charges will come on the surfaces, and they will what? Their net electric field between them is how much? 0. That means if I say the tangential component of this surface of this surface, then if electric field, then E cos theta of this tangential component is equal to 0. Why it is 0? Because they have arranged themselves in such a way that tangential component is not there. Is it clear? Their net electric field is 0 here. So it means what? E cos theta is equal to 0. It means what? Cos theta equal to 0. What does it mean? Cos theta equal to cos 90 degree. What does it mean? Theta equal to 90 degree. From there what we can say? Electric field is always perpendicular to the surface of the conductor. That is another point we have come to know. The first point is what? Net electric field in the interior of a conductor is always 0. And second point is what? Electric field outside the conductor is perpendicular to the surface. Is it clear? Is it clear? I think it is clear. Okay. We are coming to the third point. Third point is what? Net charge in the interior of a conductor is 0. When the electric field is given, the net charge in the interior of a conductor is 0. And we are going to prove it. We know according to Gauss law closed integral of E vector dot ds vector are equal to how much? 1 by epsilon into total charge. Let the charge be Q. And just the first point of this behavior of conductor in electric field, we know that an electric field inside a conductor is 0. Electric field inside a conductor is 0. What does it mean? E is 0. Is it clear? If E is 0, what does it mean? 1 by epsilon into Q is equal to 0. It means Q is equal to 0. From there, what we can say? When a conductor is placed in an electric field, net charge inside the interior of the conductor is net charge. That means what? Total charge. Whatever the charge is there in the interior is always 0. Let's go to the fourth point. Fourth point states that if there is no charge inside the surface of the conductor when electric field is applied, okay, in the interior of the conductor, in the interior of the conductor, when the electric field is applied, there is no charge. Then where the charge goes? It states that charge is always reside on the surface of the conductor. To prove it, let's take a conductor. Okay, and we have given some extra amount of charge on this surface. Okay, and now we have given extra amount of charge, so its electric field is always directed. We know that, but directed outward. Electric field always directed outward. And we have taken a Gaussian surface here. This is the Gaussian surface. As the electric field outside directed outward, so in the interior, what is the flux? In the interior, what will be the flux? It will be 0. In the interior, flux will be 0. So according to Gauss theorem, we know that phi is equal to closed integral of E vector dot ds vector equal to 1 by epsilon into Q. It means what? In the Gaussian surface, phi is equal to 0 means the total charge. Q is equal to 0. It means interior there is no charge. So where this charge goes, all these charges will come on the surface of the conductor. This is the another point. Next we are going to the fifth point. Okay. And the fifth point states that when a conductor is placed in an electric field, then total electric potential inside or any, what we can say, electric potential inside the conductor everywhere remain constant inside the conductor. And to prove it, we know that E equal to how much? Minus of dV. That means electric intensity is the negative of potential gradient. We have discussed in the last chapter. And just now we come to know that electric intensity inside a conductor when it is placed in an electric field is always 0. That means E is equal to 0. Okay. It implies what? dV equal to 0. What does it imply? It implies what? dV equal to 0. And if we integrate both sides, then we'll get what? Integration of dV as a V and integration of 0 as a constant. From there, what we can say? We can say that potential inside a conductor when it is placed in an electric field is always same. That is, it is always constant. So that is all about the fifth point. Next, move to the sixth point. Okay, that sixth point is very important one. We are going to find out what will be the magnitude of electric field on the surface of the conductor when it is electric field is given. For that we have taken a surface. We have taken a conductor like this. Okay. And we have considered a Gaussian surface here. As inside the conductor when it is placed in electric field, what will happen? Total charge and total electric field inside it is 0. Okay, so this person is out of consideration because their electric field is 0, so there will be no electric field is there. Okay, but this person, there is a electric field is there. Suppose it is directed outward. This electric field is directed outward here in this direction. So area vector is also directed in the outward. So flux, what will happen to the flux? d phi E is equal to E vector dot ds vector, and it will be how much? E ds, because electric intensity and that area vector are also in the same direction. So what we can say? We can say E ds cos 0 degree. So it will be how much? E ds, this is the equation equation number 1. From there, d phi is equal to E ds, equation number 1. If sigma is the charge density, then what will be the sigma? Sigma equal to dq by ds. From there, what we can say? dq equal to sigma into ds. Now, according to Gauss, d phi E is what? 1 by epsilon into total charge. What is the value of total charge? Sigma into ds. We have given. Okay. On this surface, total charge is sigma into ds. Now, from this is d phi equal to E ds. This is d phi is equal to 1 by epsilon into sigma into ds. So, from 1 into what we can say? E into ds is equal to sigma by epsilon into ds. So, this 2 ds will cancel out and we will get what? E equal to sigma by epsilon naught and E vector equal to sigma by epsilon into n cap. So this is about the 6th point. What is our first point? First point is net electric field inside a conductor when the conductor is placed in an electric field is 0. Second point is electric field when a conductor is placed in an electric field, then electric field is directed perpendicular to the surface of the conductor. Third point is that net charge inside the interior of the conductor is 0 when it is placed in electric field. Fourth point is what? Electric charges always reside on the surfaces of the conductor when it is placed in an electric field. Fifth point is what? Electric potential is always constant when it is placed in an electric field. Sixth point is what? The value of electric field intensity on the surface of the conductor depends upon what? Surface charge density and the what? Epsilon naught is what? Permittivity of the medium. That means E is equal to sigma by epsilon naught and its direction is given by n cap. So E vector is equal to sigma by epsilon into n cap. This is the 6th point. Now we are moving to the last point and it is the 7th point. Okay. We want to know what will be the density of the charge when it is placed in an electric field. When the conductor is placed, where will be the maximum and where will be the minimum, and whether it will remain same at every point. Let's see. We know surface charge density is given by sigma equal to charge by area. What we know? Surface charge density is given by what? Charge per area. And if we take a conductor like this, suppose at this point A, charge density is sigma 1, this point B, charge density is sigma 2, this point C, and this point C, the charge density is sigma 3. You will see that here the area is maximum, here the area is a little bit less than, and here is a point is there, point A is there, okay? And we are going to find out the electric field intensity at this, surface charge density at 6 points. At this point, you see, as the area in the denominator, if the area is less, then what will happen? Charge density will increase. So, maximum charge density is where? At the point C. And it is the area is less. But here it is minimum, because area is more. Because mainly the surface charge density depends upon the area. So, similarly, if we take a comb and if we rub it in our hair, then what will happen? It will attract a piece of paper. Do you know the reason what is there? As this comb, at this point the comb is a pointer. That means what? Its area is very small. So when you rub it, some charges are transferred to it, and if it finds any uncharged conductor, suppose it's negative, positive, uncharged conductor, piece of paper are there. So if it is positively charged, suppose if it is positively charged, then all the negative charges come here and to the track. The main point is there. Why it is attracting? Because their charge density is more. Is it clear? So from there what we can say? That surface charge density is different at different points when it is placed in an electric field, and mainly it depends upon the area where it is moving. Is it clear? So there are 7 points are there. First point, when an electric field is placed in when an electric conductor is placed in an electric field, net electric field intensity is 0 inside the conductor. Second point is electric field is always normal to that means perpendicular to the surface when it is placed in an electric field. Third point is electric total charge in the interior of the conductor is always 0. Fourth point is what? Electric, that charges always reside on the surfaces of the conductor when it is placed in an electric field. Okay, surface of the conductor. Fifth point is what? Electric potential in a conductor when it is placed in an electric field is always remain constant. That means in interior of the conductor, potential remains constant. Sixth point is what? Electric field intensity is given by equal to charge intensity by epsilon naught into n cap, because the value is in a sigma by epsilon naught. Means charge, electric field intensity depends upon the charge and also upon the permittivity of the medium. And the seventh point is what? The charge density is different at different points of the conductor because it depends upon the area of the conductor when it is placed in electric field. So this is all about here. But this is all about how the electric conductor is behaving, how it is working when it is placed in electric field. You have to go through it. Is it clear? Our next topic is electrostatic ceiling. So our next topic is electrostatic ceiling. सील करना आजकल देखा ना तो कोरोना में कहीं अगर दुकान अभी 12 बजे के बाद खुल जाएगा और पुलिस देख ले तो उसको सील कर देता है, बंद कर देता है, परमानेंटली बंद, जितना दिन तक चाहे वो बंद कर देगा, होता है ना उसका मर्जी के ऊपर। वैसे ही मतलब क्या, वहाँ से कोई सामान बाहर नहीं जा सकता या बाहर का कोई सामान अंदर नहीं जा सकता, सीलिंग बोलते हैं इसे। उसी तरह अगर मैंने एक ऐसा कोई रीजन बना दिया, इफ आई मेड एनी रीजन where no electric field can go inside, then that process is known as electrostatic ceiling. Yani the region or space where electric instruments can be protected easily, that means what? No external electric field can affect it, is known as what? Electrostatic ceiling. So here the effect is there. Suppose we have taken a conductor here. This is an unchanged conductor. And we place it in an electric field, and what will happen? This side becomes negative and this side becomes positive. So total electric field inside this one is how much? It is 0. Here the electric field is how much? 0. As the electric field here it is 0, so what we can say? We can place any instrument here and it will be protected. Clear? And now, so that is the what? Effect of, that is the use of what it is. That one is what our main theme of electrostatic ceiling, how we can protect the instrument. Now, what are the applications of electrostatic ceiling? You know, thundering is going on there. Few days ago, with the thundering, lots of people die somewhere, places, we know that. So similarly, if the thundering is there and two persons, here I am giving you an example. Two persons are there, one person is sitting in the car and one person is under the tree. Then what will happen? During the thundering, what will happen? The clouds will collide among themselves, that is water molecule will collide among themselves, and they will what, when during the collision there is a production of huge amount of charges, maybe positive charges or it may be negative charges will produce here. And this positive charges will directly attract it towards the arc, it will directly towards the downward direction. Okay. When it goes here, in the roof of the conductor, roof of the car is what? Is made up of what? It is an uncharged conductor. What will happen when the charge comes here? Then all this will become what? This band will become in the electrostatic ceiling field, because the upper portion will get negative and other portion will get positive. So here the electric field becomes 0. So he will be saved. But this person who is sitting under the tree or who is standing under the tree, what will happen? Directly charge will go to him. And he will help us, he will become a conductor and he will conduct this charge to the where? Towards the arc, and directly he will be affected. So, who will be saved? The person who is in the arc will be saved. Okay, so that is the first effect. Another effect is what in our house you will see that one wire, always in your house you will see that one wire is earthen, one wire which has no use, which is what it looks like it is earthen. You will see that if you touch it sometimes you will not get any current to it. Okay, but why it is earthen? Earlier I don't know why it is earthen, but later when we come to the class 12 we come to know why it is earthen. Is it clear? It is the main reason is what? When Again, when thundering is there, either negative charges or positive charges clouds are produced. And if the clouds are produced, then what will happen? It will affect your house. Okay. So if the earthing is there, proper earthing is there, then what will happen? This, if it is positive charge cloud, all earth is a big conductor of negative charge. So all positive charges will go there. And if it is negative charge, then this earth is a big conductor of negative charge. So directly this negative charge will come here and it will repel this one. So it will go away and you will be in the electrostatic ceiling attack to you, which will protect you from this thundering. So main use of this one is what? To protect yourself from the thundering, and maximum use of what? Here thundering is also there, and also what? Lots of instruments are there nowadays we are using. We can protect it by placing it what? In an electrostatic ceiling effect. Okay, now we are going to the main topics. What is that one? Electrical capacitance. Is it clear? Okay. We are going to start the main topics, that is known as electrical capacitance. After discussing lots of things, we are going to start the electrical capacitance. How the capacitor works. You know the formula for potential is how much? What does potential source? Potential is that V is equal to Q by R. Main formula is that is K into Q by R. What is the Q? Q is the amount of charge. So if the charge is more, potential is more. Keeping the distance constant, if the charge is more, potential is more. If the charge is less, potential is less. Is it clear? So from there what we can say? If Q is more, V will be more. If Q is less, then V will be less. And from there we can say that Q directly proportional to V. And if we equalize it, we can put C into V. Where C is a constant of proportionality known as what? Capacitance of the system. C is a constant of proportionality known as capacitance of the system. In other words, what we can say? C equal to Q by V. From there we can say C equal to Q by V. Or we can say that the capacitance is the ratio of the charge to the potential. Charge to the potential. Now if V equal to 1 unit, then C equal to how much? Q. And from there we can say the amount of charge. Capacitance is the amount of charge required to raise the potential of a conductor through 1 unit. What is capacitance? Capacitance is the amount of charge required to raise the potential through 1 unit. Is it clear? Capacitance is the amount of charge required to raise the potential through 1 unit. That is about your capacitance. Now, what are the factors upon which capacitance depends? Capacitance generally depends upon the shape and size of the conductor. It depends upon the nature of the medium between the conductor, because QV depends upon the nature of the medium, and it also depends upon the presence of other conductors in the neighborhood. Is it clear? Capacitance always depends upon what? What are the factors upon which the capacitance depends? Number one, it depends upon the shape and size of the conductor. Second one, it depends upon the nature of the conductor. Third one, it depends upon the what? Presence of other conductor nearby it. Is that clear? Okay. Now we are going to discuss about the units of capacitance. Okay, we are going to discuss about the units of capacitance. SI unit of capacitance is Farad. To honor the scientist Farad, we named the units of capacitance. SI unit of capacitance is Farad. And we know, just according to definition, that capacitance C is given by what? Q by V. If Q equal to 1 coulomb and V equal to 1 volt, then C equal to how much? 1 coulomb by 1 volt equal to 1 farad. Is it clear? If C equal to 1 coulomb, V equal to 1 volt, then C equal to how much? 1 coulomb by 1 volt equal to 1 farad. Yani, what? How can we define? We can define. If a charge of 1 coulomb is required to raise the potential of a system to 1 volt, then the capacitance is said to be 1 farad. Is it clear? It means what? If a charge of 1 coulomb is required to raise the potential through 1 volt, then capacitance is said to be 1 farad. Is it clear? And serious units of capacitance are of 2 types. One is known as electrostatic unit, another one is known as electromotive unit. Similarly, if Q equal to 1 stat coulomb and V equal to 1 AB volt, then capacitance C is equal to how much? 1 stat coulomb by 1 stat coulomb by 1 stat volt, and the result will be how much? 1 stat farad. From there, what we can say? If a charge of 1 stat coulomb is required to raise the potential of the system through 1 stat volt, then the capacitance is said to be 1 stat farad. Is it clear? If a charge of 1 stat coulomb is required to raise the potential through 1 stat volt, then the capacitance is said to be 1 stat farad. Is it clear? Same, if Q equal to 1 AB coulomb and V equal to 1 AB volt, then C equal to how much? 1 AB coulomb by 1 AB volt, and it will be how much? 1 AB farad. So there we can say that if a charge of 1 AB coulomb is required to raise the potential through 1 AB volt, then you can say it is what? 1 AB farad. Is it clear? So there are 3 definitions are there. One is farad, second one is SI unit is what? Farad, electrostatic unit is what? Stat farad, electromotive unit is what? AB farad. Again I want to define it. Farad. How can you define farad? If a charge of 1 coulomb is required to raise the potential through 1 volt, then the capacitance is said to be 1 farad. Again, if a charge of 1 stat coulomb required to raise the potential through 1 stat volt, then the capacitance is said to be 1 stat farad. Again, if a charge of 1 AB coulomb is required to raise the potential through 1 AB volt, then it is said to be 1 AB farad. Is it clear? These are the definition, and our next topic is what? We are going to find out the relation between farad and stat farad, farad and AB farad, and we will find out the relation between farad and stat farad. Is it clear? Okay. Now we are coming to the discussion, the mathematical discussion of how we can find out the relation between farad and stat farad, relation between farad and AB farad, relation between farad and what is that one? Relation between stat farad and AB farad. Is it clear? So we know 1 farad equal to how much? 1 coulomb by 1 volt. And 1 coulomb equal to how much? 3 into 10 to the power 9 stat coulomb. And 1 volt equal to how much? 1 by 300 stat volt. So the result is how much? So the result is 3 into 10 to the 11 stat farad. Is it clear? Again I am repeating. We know 1 farad equal to how much? 1 coulomb by 1 volt. Equal to how much? 3 into 10 to the 9 stat coulomb divided by 1 by 300 stat volt. So the result equal to how much? 3 into 10 to the 11 stat farad. Again, relation between farad and AB farad. We know 1 farad equal to how much? 1 coulomb by 1 volt. So it will be how much? 1 by 10 AB coulomb divided by what? 10 to the power 8 AB volt. And the result will be how much? 1 by 10 to the power 9 AB farad. And when you go to find out the relation between stat farad and AB farad, how can you find out? Let's see. We know 1 farad equal to how much? 3 into 10 to the power 11 stat farad. And 1 farad and also 1 farad equal to how much? 1 by 10 to the power 9 AB farad. So 1 by 10 to the power 9 AB farad equal to 3 into 10 to the power 11 stat farad. And the result will be how much? 1 AB farad equal to 3 into 10 to the power 20 stat farad. Is it clear? Here again I am repeating. 1 farad equal to 1 coulomb by 1 volt. So it will be how much? 3 into 10 to the power 9 stat coulomb divided by 1 by 300 stat volt. And the result is 3 into 10 to the power 11 stat farad. Relation between farad and AB farad. We know 1 farad equal to how much? 1 coulomb by 1 volt. equal to how much? 1 by 10 AB coulomb divided by 10 to the power 8 AB volt equal to how much? 10 to the power 9 AB farad. Correct? And relation between step farad and AB farad. We have 1 farad equal to 3 into 10 to the power 11 step farad and 1 farad equal to 1 by 10 to the power 9 AB farad. So 1 by 10 to the power 9 AB farad equal to how much? 3 into 10 to the power 11 step farad. So 1 AB farad equal to 3 into 10 to the power 20 step farad. So these are the relations between farad, step farad, farad, AB farad, and lastly AB farad and step farad. Is it clear? This relation is very important. Now we are going to know about the dimensions of electric potential. Sorry, electric capacitance. We know electrical capacitance C equal to how much? Charge by potential. That means Q by V. Again, what is the general formula of potential? Work done per unit charge. So it will be Q divided by W by Q. So the result will be how much? Q square by W. And what is the dimension of Q? Q is equal to what? Generally Q is equal to I equal to Q by T. So Q equal to how much? IT. So the dimension of Q is what? A into T. So it will be AT whole thing square. So it will, and dimensional formula what done is what? M1 L to the power 2 T to the power minus 2. So the result is 1 to the power minus 1 L to the power minus 2 T to the power 4 and A to the power 2. So the dimensions are minus 1, minus 2, plus 4, plus 2 with respect to mass, length, time and electrical. This is about your dimensions of capacitance. So we come to know, today we have learned, what are the things we have learned? What are the things we have learned? We have learned what is conductor, what is insulator, we know about the free charge and bound charge, we know what are the different properties, what are the different properties, what are the different behaviors of conductor when it is placed in electric field. Then we come to know what is capacitance, we come to know about the electrostatic ceiling also, we come to know what are the factors upon which electrical capacitance depends, we come to know the different units of electrical capacitance, and lastly we come to know what? About the dimension of electrical capacitance. So it is okay today, friends. Tomorrow I will give another video for you about that details of the capacitance of isolated spherical conductor, and please be regular and visit this one video directly every day. Please revise that video every day. You please go through the video. If you are having any time, don't waste your time. You have lots of time out there. Nowadays no school is there, no tuition is there. Now where you have to go, just watch the video regularly, all the videos regularly of this my classes, then you will see that you find that physics is easier for you. Okay, thank you, have a good day.